Hello and welcome back to KXAM Plus. I'm your host, Esmeralda Zamora, and this Tuesday we have our space-based segment with our KXAN space expert, Eric Henriksen. Eric, thanks for joining me. How are you doing?
Good. I was going to be really serious there at the start. I couldn't do it. I couldn't force myself to be too serious. I'm doing good. It's a great day. It's lovely out. It's not too hot yet. I think we're getting the 90s today, actually. Honestly, I haven't looked, but it wasn't too bad this morning. I'm in a good mood, good place. I'm finally waking up. I'm on my second cup of coffee, so... We're getting there.
Yeah, you get here really early, so this is like midday for you, right?
I'll be honest, today I slept in and didn't get here till 7.
Wow.
I was trying to get here at like 6, and I just my dog was laying next to me, and I just kept hitting snooze.
That's the best, when your pups are cuddled up next to you.
And he's big now, too. He's kind of like, when we got him, we found him at Taco Bell on the street, and he was that big. He was 2 weeks old, and now I can't even do it. The camera's not even big enough. He's like a 50-pound dog. And so he takes the entire bed, and he was just cuddled up super tight against me this morning. And I was like, well, can't wake up now.
Well, he said you have to stay in bed. You got to stay in bed.
Yep, and he's big. He can make me if he wants to. So a little big man. That's why I'm my little big boy. There's a song I sing. I won't sing it here due to copyright infringement.
But he has his own jingle, I bet.
He has his own jingle. All the dogs get a jingle. Yeah, all of them do. Well, all of them will get me sued for copyright infringement, too. I just changed the name. Yeah, what can I do?
Cute. Well, this week seems to be your week with lots of space news in our radar, right?
Yeah, there was a lot. I got to report on space yesterday on KXAN at 5, and so we're going to talk about that story and kind of carry this over from that. But on top of that, there was a lot of things I didn't even get to cover in that story that I still want to cover. And actually, there's a couple things I'm still working on interviews for that I haven't had a chance to set up fully yet, so I'm hoping to get those for a future story. So yeah, this has just been really busy with the space industry right now, and we have a lot to talk about. The first thing I want to talk about is NASA, because I think this is pretty big news. They announced last week that about 20% of their workforce will be taking early retirement. This is due to budget cuts. We've talked about this in the past a little bit, but President Trump's budget for NASA decreased the size substantially. As a 24% cut to the overall budget for NASA. And as a result, they've offered kind of early retirement packages for a number of people, include about 4,000 people, less than 4,000 people are going to be expected to leave. So about 3,000 are opting to leave, 870 are opting to leave during the first round of early retirement, and about 3,000 on the next round. This is going to reduce NASA's size from about 18,000 people to 14,000 people.
Wow. And by what year are they expected to leave NASA?
So this is by 2026 is when they're going to start. This is when the second round will happen. So you'll have a first round relatively soon and a second round kind of further out. I have stats here. I'm looking down at my stats because I wrote down a bunch of numbers. Nearly 50% cut to the science division's budget.
Wow, that's a lot.
That's a lot. So that tells you kind of where the priorities.
What kind of impacts is that going to make on that section of NASA?
Ooh, a lot. Technology probably won't be as impacted, but there's going to be some of our projects to monitor, like the climate, which the administration has deprioritized compared to previous administrations, monitoring the climate, monitoring the weather. This will have an impact on us here at home, especially when it comes to like the weather monitoring, that some of the scientific data we pull to determine when we're going to be hit by a hurricane. That will not be as readily available over time. So that sort of reduction is going to be pretty big.
This rolled out in 2 phases. Why did it roll out in 2 phases?
I think just because of the number of people being let go, you can't just like say, okay, 4,000 people need to leave. They offer these retirement packages, right? But you can't just say, hey, 4,000 people need to leave now. And before that, they get a paid administrative leave. You have to phase it out so some of these projects that they've already spent billions of dollars on don't just end abruptly. They can kind of wrap things up to some degree. There was a declaration called the Voyager Declaration that was 300 NASA scientists signed last week that said doing this will jeopardize U.S. leadership in space and threaten mission safety and progress. Don't forget we have astronauts in space right now, and we're trying to build new space stations closer to the moon and travel to the moon. And if you reduce the staff, you reduce the amount of research going into these things, there is a cause and effect. And so we're not going to know the full effect that this will have for a number of years, but we'll find out. Interestingly, though, as we deprioritize space travel on the federal level, the private sector is growing. last month, a group called Pulsar Fusion announced plans to move from the UK to the US, to Austin, Texas specifically. This is a group that's developing fusion-powered nuclear energy engines for space travel.
And in your bullet points that you shared with me on this specific topic, at the very end, it says it will threaten mission safety and progress. What
Yes.
did you mean by that?
That's literally like if the scientists aren't there to determine possible problems that could occur on a spaceship, you are putting people in threat. You're putting people in danger. You need people to work on these projects.
Yeah.
So
Well, although NASA is making some cuts, we do know that there are some new growth in
Yes.
space
So-
industry workers, stuff like that, right?
two big ones. And so Pulsar Fusion, like I mentioned a moment ago, they're moving to Austin. But on top of that, the Texas Space Commission, which was established in the previous legislative session, and I'm kind of curious, can I keep saying previous? I guess we just wrapped up one.
We just wrapped
The
it
previous,
up.
the 2023 legislative session. That was established by the Texas Space Commission was established then, and one of the things they're doing is taking $150 million worth of grants and divvying them up. And they just did a new round of funding last Friday.
Wow.
And Pulsar Fusion announced their plans to move here in June. And we have my full story from yesterday. And let's take a look at that.
Let's listen to it. We're having some technical issues. Let me pull it up manually. We got it.
We'll do it. We got it covered.
Should be this.
From Firefly Aerospace to SpaceX,
Copy 1 Alpha.
more and more aerospace companies are calling Austin home.
There's just a really great environment in Austin. A lot of the space people that we know are there.
Pulsar Fusion, a UK-based rocket propulsion company, announced in June their plans to open a US headquarters in Austin.
The Austin move is really about a project called Sunbird, and that is all fusion.
Founder and CEO Richard Dinan said that the area has the resources they need to build nuclear-powered engines in space.
On the outset, it's wild. You're talking about a nuclear fusion, which is hard enough, and then doing it in space seems completely, almost too exciting.
The company, which already makes propulsion systems for satellites, say that Songbird engines will attach to spacecraft in orbit, then launch them to Mars and even further.
Nuclear fusion propulsion is an incredibly real, potentially even nearer term objective than fusion for energy.
Last Friday, the Texas Space Commission announced another $9 million grant to boost space exploration projects in the state. In May, the commission gave $10 million to a different Austin company, CCM Astro. For Pulsar Fusion, these investments are a reassuring sign that Austin is the place to be.
If it stand a chance, it's going to be the capabilities and the community in Austin area that it's all there.
Eric Henriksen, KXAN News.
Austin is the place to be, apparently.
Austin's a place to be. I was trying to come up with a list of all the aerospace companies we have here, and it was hard because some of them are smaller companies that work on little space parts, and some of them are bigger companies that are working on rockets, like Firefly Aerospace, SpaceX, which is coming here. They're not quite here yet. They're in Texas, obviously.
SpaceX is coming
Excuse
to
me.
Austin?
Yeah, they're gonna open a new facility for manufacturing Starlink satellites north of Austin. I looked at a map yesterday where it was. It's like northeast of Austin, kind of heading up towards, was it Tyler area? No, that's near Dallas.
Cedar Park?
No, way past Cedar Park. It's like northeast. It's more like Temple.
Temple?
Like almost heading
Killeen?
towards. Yeah,
Like that
Temple,
area?
Seguin, that kind of area is where it's at. I looked at a map where they're building that facility now, but they also have the X offices are here and the Boring companies here, so that Elon Musk's companies have kind of chosen Texas and Austin as their home. So it makes sense they'd have a facility here, but they also have Starbase down in off the coast, down there closer to the border, where they do most of their SpaceX stuff. So we had a few here that we looked at, and actually I'm trying to set up an interview with a different one to chat about some of the stuff they're doing. But the Texas Space Commission, I've talked to them a number of times, talked to them yesterday about this story. They have approved 22 projects so far, and of the $150 million they were given to grant out to different projects, one of them was the city of Midland is trying to build something that's related to space.
Wow.
So they're giving these grants out to any group that's working on a space project. Not any group, but they have to apply. There's $150 million total. They've used $126 million. One of the cool ones outside of this is they also are overseeing the construction of a new research facility outside of NASA that's run by Texas A&M that will work on lunar rovers and stuff. I was there at the ribbon cutting for that last year and saw some of the experimental lunar rovers they'll be testing at that facility. Pretty cool stuff.
Pretty cool, and I'm sure you're going to be right there when it happens.
Oh, yeah. I think it's supposed to be opening, what is this year? I think it's next year. I think it's 2026 also.
Mm-hmm.
Yeah, I think that was the plan. It's been a while since I talked to them, but pretty cool what they're working on. The next thing I want to chat about is we had a new satellite launch last week. Did you see it? Did you see it?
No, I didn't see it, but we do have the video, so we can see it now.
Yeah,
right?
I forget what I picked out. I think they were just like some generic
The tracer.
satellite. There it is. It's called
There it is.
tracers, plural.
Tracers.
Because there's two of them.
Oh wow, they're like sisters.
They're sisters. So what tracers is all about is space weather. It's all about studying space weather. Do you know what space weather is?
No, but I do know you spoke with someone who explained what space weather
Yes,
is.
this is NASA's head of their, I hate this word, it's hard for me to say, Helio Science Division. And he talked a little bit about what space weather is and why it matters. Here, take a look at that.
Heliophysics is that study of how the sun connects to the earth, right? How the sun affects everything in our solar system. Space weather is the applied aspect of that. So when we think about, our daily lives and how the solar wind, how solar flares, how changes in the sun and the space environment around us affect the things that we use on a daily basis, that's space weather. But it affects things like communications. So high frequency communications that have to go through the Earth's ionosphere. It affects the GPS signals that we rely on all the time. I don't know how to get from point A to point B these days without a GPS. And the GPS signals have fed into so much of our technology, whether it be, getting from point A to point B, but also GPS, precision GPS is being used over and over again in things like precision agriculture. This year, we saw in May some of the precision planning activities that were happening were sidetracked for a couple of days because of one of these large solar storms.
So not rain in space.
No,
but
no.
Space
Solar
weather.
storms. That was Dr. Joseph Westlake, Heliophysics Division Director, where they study helioscience. Helio is Latin for the sun? Yeah, Latin. Let's say Latin. I'm pretty sure it's Latin.
I'm not sure.
I know my Latin is rusty, as is the language itself. Dr. Joseph Westlake, he is with NASA. So Helio, space weather is caused by the sun. Sun has coronal mass ejections, which is one of my favorite words, and solar flare. And when these things hit us, we get like these magnetic storms. And I actually have really cool videos. So these are the satellites. There's another one we had. I'll pop that up because it'll show you what we see as space weather. And it's there you go. That's what space weather looks like. The auroras,
borealis? Yeah.
That is when it hits, when the energy from the sun hits our magnetosphere. Every 11 years, the weather on the sun increases. We're at the back end of it. The last year was the peak of that 11-year cycle. This is the year after the peak. So we're coming off the mountain, and so we're seeing less of these than we did last year, and we'll see less and less and less, and then none, and not none, but very, very few.
How long is it going to take to get to none?
11 years divided by 2 is 5.5 years. So I guess by this point, 5 years from now, roughly.
Pretty soon.
Relatively, yeah. And then it'll come back. Then 11 years from now, we'll be back to a peak. Or I guess 10 years from now, we'll be back to the peak. So it'll kind of cycle. It cycles up. So we get hit by these storms, and like you said, like they interfere with our GPS. They interfere with our weather satellites, our satellites in space, our astronauts, everything we have above the magnetosphere, which protects the Earth. Which, when the storms hit the magnetosphere, we get those storms, the aurora borealis, which shows where we're being hit. But above that, where we have all these satellites that provide so much information and things to us, including this very live stream that we do every week, it interferes with those things. It's like a little EMP gain hitting those things. And we do build them to be protected, but we need to know more about it. And Tracers, which launched last week.
July 22nd. Right?
July 22nd. Yeah, that was, he threw me off with the date. I was like 6 days ago is how I had it in my head. It launched, the 22nd.
SpaceX launched this?
Yeah, it was on a Falcon 9 rocket. So they launched it on a Falcon 9, and because that's kind of like what they do now.
I guess.
It's just, that's like the main rocket that NASA uses. Yeah. But it's two different, I'm doing my hand gestures too low. It's two different satellites, and they kind of separate and
Break off.
right. And Dr. Westlake kind of explained why we
Let's
need
see
those.
if we can see your hand gestures
Can we
better.
do this? Is that better? Yes, they break off and they create like a net kind of where they can kind of study the stuff as it goes through. So Dr. Westlake kind of explained, I got you that soundbite right, why they need to break off this way and scan the space this way. So take a look at this.
We want to be able to take a coronal mass ejection, a flare, one of these large active things that happens from the sun. We want to be able to predict and forecast it. We want to be able to deliver accurate understanding of how that's going to travel through space, and then tell people right away whether or not it's going to affect their daily lives. Right. So this kind of mission allows us to really help connect those different pieces. This is one of those key longstanding mysteries about our system.
I failed you. That was there was a different soundbite I was
I was like,
referring
what
to.
is he talking
And I
about?
wasn't that. I just explained why we need this. Why we need this mission. But the different soundbite, which I did not include and did not send you, basically explained why they fly them separate, and it's by having both of them detect, like send signals to each other, they can detect changes in the magnetosphere. So they're able to do that. I need to move my hands a little closer while I'm gesturing by using them in tandem. There's another satellite I did a story on a couple years ago where it was like two boxes and they had a laser connecting them, and as they moved apart, they could tell like down to the micron the distance changes, and they were using that to detect gravitational changes on the surface of the planet because the surface isn't fully perfect. It's like gravity's not like the same everywhere.
Yeah.
It's like slightly different. So by these little changes in their movement, they could tell the difference. And this kind of does something similar by doing these little changes, electromagnetic stuff. They can tell the changes. So it's pretty cool. That's launched. It'll be up there for probably 3 years, and then we'll see how long it lasts after that. Typically, these missions are about 3 years, and they try to stretch them out, get more data out of them. And we'll learn more about forecasting solar storms, which is kind of the big idea here.
And they're already out in space.
Yes, they launched 6 days ago.
A week ago, something
A
like
week
that.
ago, yeah.
And he mentioned that it does affect our daily lives.
Yeah, that's 100%. The way we like I mentioned, the GPSs we use, weather satellites we use, the astronauts in space, getting this very live stream through the internet. The internet's crazy. You ever think about how crazy the internet is? You send a signal from this to space and
you
then
can't
back.
see it, but it's there.
It's there, right? And so without these satellites, we can't do that. And without figuring out how to forecast and protect them better, using these missions like Tracer, we're gonna be in trouble.
Yeah. Well, this is not the only topic that we're talking about today. The next one
Right.
is what I've been waiting for to talk about.
Yeah, you want to talk about this. This is my final thing today. Astronomers detected a young star, I'm trying to get the name of it right, called V883 Orionis. It's located 1,300 light years away, so that's 1,300 years away, essentially. And they detected, the solar system's really young, but they found organic matter, the same organic matter that creates life. And that's where the galaxy is, but they found them. And the ones are, again, rough on the Latin, but ethylene glycol and glycolin nitrate. It's a precursor to amino acids like glycine and alanine. We need amino acids to create life.
So there's life on this star?
There is the potential for life.
Well, let's just say there's some aliens on that
There
star.
is no aliens on the star. It's too young right now is the thing. It's going to be several billion years before it becomes a full thing. But it's a very, very young solar system. So far, of all those, 17 organic compounds. These organic compounds were detected using some of our advanced telescopes, which can observe. And there's several telescopes involved in this. Do not ask me to name them. But there's several.
Give us one name. Give us one
Do I
name.
have one here? Did I write down any of their names? I did not, did I? No. Oh, yeah, I did. ALMA. I did write down the ALMA telescope in Chile. That telescope was the main one that detected, but we used several others too.
We talked about that one before, right?
We have talked about ALMA before, yeah. So we're going to use more advanced telescopes to determine more of them. But again, these results are kind of like early on. One of the scientists who worked on this project kind of explained why, what the information kind of tells us and what we can learn from it. Here, take a look at that.
What this tells us is that we can get pretty far along the ladder to life before we even have a planet. So one of the really big questions in astronomy right now is, are we alone? How unique is Earth? Did something very special happen to allow life to emerge here? Or are the ingredients for life really common? And so that we are seeing these really complex molecules that can go on to be ingredients for life in this environment where we know planets are forming, that suggests that these sort of prebiotic molecules are very common.
That's a spooky question. Are we alone here?
Are we alone? Well, if you think about the math, the universe is infinite, and it's happened here. It could happen somewhere else.
Yeah.
So that's how I see it. However, it may just be the universe may be still just too young to see it everywhere. So what we are seeing though is the ingredients, the building blocks,
Yeah.
which imply that life can find a way, and we'll see that hopefully, and hopefully our lifetimes will find proof. I think we're finding proof that life can exist. So if there's amino acids, that's a sign that building blocks.
It's possible.
If the building blocks are there, the foundation's there, maybe there's a house. You never know. This is again, it's a very, very young solar system. It's a very young star. The planets aren't even there yet.
Yeah.
Like she mentioned. So
How far away is it from us
it's
again?
1,400. So I said 1,300 light years away. So about
Wow.
1,300 years away by as fast as light travels.
Amazing that we saw this, that we caught it.
Oh, yeah. I mean, we've talked about this in the past, but the universe is so big that when you catch stuff, you catch it, right?
Mm-hmm.
It's, you kind of stare at, I talked to astronomers before, they're like staring at like this,
Just staring at tiny little
like
specks
the
all
eye
day.
of Abraham Lincoln on a penny. And that's all they study for years.
That's
But the
crazy.
amount of information in that eye, if you're staring into the infinite, there's so much stuff there over the infinite. It's just you gotta catch it.
You don't know if it's a speck of dust or it's a planet full of
Right.
aliens.
And luckily we have telescopes that can they do it through like detecting light. I really don't understand it fully, to be honest. But by different wavelengths in light, you could determine what molecules are in a thing that you're looking at. It's essentially like through light, they can tell, like, I think it's, let's say sulfur, for instance. Sulfur glows yellow green
Yeah.
when you burn it. So by different things emit different colors, and you can kind of determine compositionally how they're made up.
Mm-hmm.
Again, I don't fully understand it. It's one of those things that's like, they explain it in science class. I've talked to scientists about it. My brain just doesn't quite compute it. I know that they're able to look at something and go, that's using the full wavelength of light beyond just a visible light.
Yeah.
That thing there is made of carbon. That thing there is made of iron. That thing there has amino acids.
Yeah.
That thing there has complex molecules that are needed to make life. We talked about last week? We talked about the Goldilocks zone.
Yeah,
where-
I think so.
Yeah, between like where we think life can exist, where it's just hot enough and just
And
cold
where it
enough, and it's right in the
clearly
right
cannot
spot.
exist.
Right,
Yeah.
and Earth's in that zone. So we're also looking at those places across the universe, and so hopefully, within the next 100 years or so, we can prove that life
Does
is out
exist.
there. Yeah, I think we're close. All we need is like one rock with one single cell organism.
I
'Cause
mean, that's how we started, right?
right. If you can find a single cell organism, that's proof enough. That's all you need, and it means it's out there.
Yeah.
So hopefully we'll find out relatively
And
soon.
hopefully we'll be around when that happens. 'Cause
I mean,
wanna
I
see
hope
it.
so. I hope it happens within my lifetime. If not, we'll see it on the next round. Who knows? We'll see what
Yeah.
happens. But anyway, that's what we got today. Cool stuff, I think.
Lots of stuff today.
Lots of
space
stuff.
news.
Some sadness about NASA. We've been talking about this for a while. Their budget cuts and the greater impact it's going to have. But if the thing is, they can always put more money back in next year.
And we also have all these new companies that are helping us.
Right, and they have a lot of private companies. They're privatizing space. This is always going to be the long story, is you're going to see the shrinking of the federal space business, but the increase in size of the private business. As this has been happening since, you look back at exploration throughout history, human history, and that's kind of what happens. First, the kings and queens sponsor the trip, and then, was it the East Indian Trading Company? They were the bad guys in the Pirates of the Caribbean movies. But like
They come
would,
and take over everything.
right. Then the private companies come in, and that's just kind of how exploration happens. This is always bound to happen. You just don't want it to shrink so much that you lose science in the process.
Yeah, and we hope that does not happen.
Right.
We do have your article that you published
Yes, yesterday. Looking at the local growth in the space industry, and it's still big and still growing, and we'll continue to cover it in the future. And again, like I said, I'm working on a couple other interviews with some local companies that we haven't talked to yet, and some of them have received funding from the Texas Space Commission. So I'm curious what they're using it for and what the Big Nix project is. Space business in Austin is huge, and it's really
growing.
cool. It's really cool. It's growing and it's growing and growing. And Texas is growing and growing and growing. And it's a great place to be when you're talking about space.
Yep, especially for you, our space reporter.
Yep. Big old space nerd over here for sure.
Well, we'll see you again next Tuesday talking more about space news. If anyone is interested in watching videos like this one or other exclusive content we have here at KXAN, please download our KXAN Plus app. Eric, where can they download
You
that?
can find it on Apple, Roku, Fire Stick, and now my personal favorite, a Samsung TV, because that's what I
Samsung.
have.
Me too, and we have Samsungs all over the station, so we should have already had Samsung, but we have it. And
Yeah, I
it's
think it was
here.
just, it's one of those like technical,
Yeah.
build it things. It's just like a little different infrastructure or something.
Mm-hmm.
I don't know.
Well, we got it. We got all the platforms. Please download them. They're completely free on your streaming app store, wherever you get your streams. You can download that there. You can watch us on KXAN.com or our mobile app. Continue watching content like this and others that we have exclusively for you from KXAN Plus. Thanks for joining us, Eric.
Thank you so much.